Welcome to the Journey Shake Chem. I'm so excited because we have the final day of the lab, the titration lab today. So I could almost do a dance, but anyway, I guess we should move on. Please do the 2 warm-up questions to the best of your ability, and we'll discuss them in a moment. Number 1 is what we did yesterday in the titration lab. We were standardizing the base, and this is very much like what we did. You are given 10 milliliters of a 0.15 molar of a standardized acid, meaning that we know specifically that the concentration is indeed 0.15 molar. Well, we're going to use this equation, which is very, very useful for us. The molarity of the acid times the volume of the acid equals the molarity of the base times the volume of the base. And this works especially well when we have a one-to-one relationship. Well, we are solving for the molarity of the base, and you know that I always like to rearrange the equation first. And therefore, the molarity of the base is equal to the molarity of the acid times the volume of the acid divided by the volume of the base. Now, the molarity of the acid was given to us. It is 0.15 molar. And the volume of the acid was 10 milliliters. And 10 milliliters must be changed to liters because molarity is in liters, and therefore a volume must be in liters. I divide it by the volume it took to get pink, and that's exactly what you're going to do. You're going to either take the best pink color that you got, or I should say that we got, or you are going to take an average of those values. And then the volume that it took to get pink was 25.5 milliliters, and I must change it to liters. And therefore, this value is 0.0255 liters of my base. And when I do the math here, I'm going to get the molarity of the base is 0.05822. Then I want 2 significant digits in my answer. The 2 does not round the 8 up, and therefore my answer is 0.058 molar of my base. And that's how you do number 1. Number 2 is a sample problem very similar to what we are determining today in the lab, the molecular weight or the molecular mass of an unknown acid. Well, we are given a 0.2 molar solution of the base. And we know that when we reach the equivalence point, or when it turns pink, it is a one-to-one relationship. Therefore, the amount of hydrogen is equal to the amount of hydroxide. The amount of hydronium is equal to the amount of hydroxide. So therefore, I can take this molarity and I always rewrite it to what it means. I have 0.2 moles for every 1 liter. I want to know how many moles it was to turn pink to get to that equivalence point. And the problem tells us that it was 33.5 milliliters. And I must change my milliliters to liters. And therefore, this value is 0.0355 liters. And therefore, when I do the math here, I get the moles, which is 0.0067. It comes out exactly, and you know I like 4 digits, so I will just put the zeros. Those are the moles of my base. However, we know when it turns pink, it's also the moles of the acid. And I know that I weighed out 0.2 grams of the unknown, just like you are going to weigh out 0.5 grams. And I have 0.0067 moles that was determined from the titration. And when I do the math here, I get 29.8507. And you'll recall that we always take the AMU, the molecular weights or molecular masses, to the tens place. And therefore the 5 rounds the 8 up. And my final answer is 29.9 grams per mole. And that's what we're doing today, and I'm so excited, I just can't wait. And I will see you back in the lab. Here we are on day 2 of our acid-base titration. Well, first I must weigh out or get the mass of 3 samples of my unknown acid. It is monoprotic, which means it has 1 hydrogen, and that's extremely important in our titration because our base is also 1 hydroxide. And as we neutralize the 1 hydrogen with the 1 hydroxide, it will change to the pink color upon neutralization when we have equal amounts of the hydrogen and the hydroxide. It's very critical for this is our quantitative analysis. Well, first I'm going to measure out my weigh boat empty, and I'm going to zero it. So I know that the only mass here is the mass of my weigh boat. Then I will put 1/2 gram, 0.50 exactly, of my unknown acid. And here we go. We're very close. And we have a bit much here, and therefore I'm going to remove this, take a little bit off here, put it back, tap ever so gently. I will use one of these weigh boats for my extra, because I never put materials back. 0.50 grams for my first sample. I will set that aside and we'll try again with another weigh boat. Not try again, just make another one. Another one. We need 3 samples. I will zero out my weigh boat. Then I will measure out 0.50 grams again. Just a tiny little bit more. And there we go, 0.50 grams of my second sample. Then I will do my third sample of my unknown acid. Weigh boat in the center, zero it out, and commence measurement. And there we go, 0.50 grams for my third and final sample. We will titrate 3 samples. I'll see you at the lab station. Here we go at our titration to determine the molecular mass of our unknown acid. Well, I have weighed out my samples here. I'm going to rinse my Erlenmeyer flask one more time. And then I am going to put the sample into my Erlenmeyer flask. I don't want to lose any of my acid. I will rinse it out with this distilled water because I'm going to add distilled water as well. And the amount of distilled water is not critical because it does not change the number of moles. However, I do want to get all of the acid out of this whey boat. Then I will add 40 milliliters of my distilled water. As well. Then I must have my indicator, critical component, 1, 2, 3 drops, and I will swirl it in order to get it to go into solution. I want it all to be in solution. My purette is set, ready to go on the 0. Just need to get this unknown solid acid into the solution. And we're almost there. A few little granules, must get them all into the solution. All right, it is in solution. Now my burette is a little low, so I'm going to turn it and make sure that it's level here, and then I will begin to titrate. I'm not sure what volume it will take this first time. It's very well possible that I may go over the end point, but I'm doing it 2 more times after this. So we'll make sure that one of our values will be the lightest and faintest of pinks. Pink is staying longer. I'm getting close. I'm going to turn down the speed here. And I'm going to go down to drop by drop here. Practicing my patience. Very, very close. And there we go. Beautiful pink color. And we have a volume of 26.8 milliliters for my first titration. Pretty good for the first time. Now I will rinse this out. Record my 26.8. And we will try again. I will put my sample into my Erlenmeyer flask. I want to get all of the acid into the Erlenmeyer flask here. Then I'm going to add 40 milliliters of distilled water. It's a little bit much. And as we said, it does not change the number of moles, so it is not critical. I add it to my Erlenmeyer flask. Can't forget the indicator. Oh, 4 drops is fine as well. Then I'm going to swirl, and I also want to refill my burette with the base. Get it on the 0. It's a little above the 0, but we can handle that. Our little eyedropper. A little fraction more. And we want to start on 0. Then I need to swirl a little bit more. And begin to titrate. Now I know it's approximately 26, so I can go quickly to the 26 as soon as I get all of this into solution. And being a little stubborn there, but that's fine. We just keep working, working, working. Actually, I'm having a great deal of fun being here with you and titrating. I think it's almost all in solution. Okay, well, here we go. We're going to go quickly down to 26, or maybe 25, just to be safe. I will continue to swirl. I see the pink forming, so I can verify that this is indeed with indicator. Sometimes we worry that we don't have the indicator, that we forgot it. And there we go. 26.9 this time, 26.9, and that is a beautiful pink color. 26.9. Now for the final one, I will rinse out my Erlenmeyer flask. And add my acid, sample 3, rinse it down, and then add my 40 milliliters of my distilled water. I'm not extremely concerned, as we've said numerous times, about the amount of water. Then I will have 3 drops of my indicator, approximately. Oh, that was 4. And then I'm going to put my burette back to 0, or 50 milliliters actually. I think that's very, very close. And we're on 0 again. Now I'm going to swirl this. Make sure it all goes into solution. This is my final titration time, and I got some beautiful pink colors. I know if you were doing this, you would have to have a little bit of practice in doing this, but as you can see with 3 trials, there's practice. Nothing wrong with doing it more trials as well, because it is graded on accuracy, and when you go on in school, there will be a number of labs that will be graded on accuracy, because in chemistry, we can do quantitative measurements. Almost into solution. There we go. Now, let's do our final titration. I'm going to go ahead and go down to in the 20s because I know it's going to occur. I think I'll go drop by drop now. Oh my. There we go. That's a beautiful pink color. And it will lighten up as we go. And my final measurement is somewhat different. It seems to be 25.6. 25.6 milliliters. Well, because this is different than the other ones, I believe that we should take the average of the 3 measurements. 25.6 milliliters for my final volume. Well, that was some fun, and now we can determine the molecular mass of our unknown acid. Thanks for being here, and we'll discuss it on the next time we're together. Can't wait to see you then. Bye.